So if you're somebody who is actually willing to prepare for system design interviews and you are confused what to study, what is the sequence to study, what are some of the important topics that are very frequently asked in interviews, then you are at the right place. So I'm Sanket Singh and I recently gave a lot of interviews for low-level design, machine coding and high-level design for different set of companies including Microsoft, Uber, Walmart, Flipkart and many more. And in this particular video, I'm going to give you a step-by-step, sequence-by-sequence flow of what are the most important things that you should definitely learn in system design, both for low-level design and high-level design. I'm going to talk about sequentially that first, what are the set of topics that you need to have, then what are the set of topics you need to have and so on, kind of like in a topological order, so that you have a proper roadmap, you have a proper syllabus with you that you can actionably start working on. This is going to be kind of like a video where I will be giving you all the important topics, and this is coming from my own experience and my own preparation strategy as well, because I had to also prepare for all of these interviews. So this is going to be a super important video. Let's start with that, and if you have any questions, do drop them in the comment section below. I would be really happy to answer all of them. That being said, without any further ado, let's just start. But before starting the video, if you have not yet subscribed to the channel, please do consider subscribing, because we are going to put some really awesome content regarding tech and career on this channel. So let's just start. So before moving forward in the video, I would like to talk about the new System Design 2.0 cohort that we have recently launched. If you're somebody who is actually willing to apply for a lot of product-based companies and you are technically confused on where to actually prepare for low-level design, high-level design and machine coding rounds, then you are actually at the right place. In the new System Design cohort, we are going to actually include all the relevant concepts around high-level design, low-level design, machine coding, and this time we have kept it kind of like bigger and better. This time we have specifically added a lot of company-specific interview problem solving, both in HLD and LLD. We have added interesting concepts around distributed system like Lamport clock, vector clock, consensus algorithms and whatnot. The complete curriculum of this System Design 2.0 cohort is mentioned in the link in the description section below. You can use this coupon code coming on your screen to get massive discounts altogether. There is a dedicated video on the channel where you can find all the details regarding the course syllabus. But what I can assure you is, based on my experience working as a software engineer and all of the interviews that I have given, this is going to be a very comprehensive course where we are going to talk about all the relevant things that is going to be necessary, not just for you to crack software engineer interviews, but also work as a software engineer. So do check out all the links in the description section below. All the course syllabus, all the dates, everything necessary is already mentioned there. So now let's come back to the video. Okay, so now let's start with the low level design part, right? Now, in any system design preparation, of course, there are going to be two aspects to it. One is going to be the low level design, one is going to be the high level design. First of all, we are going to focus on everything that you need to do step by step for low level design, right? We are going to go extremely deep, and you need to also keep one thing in mind, that whatever topics I'm talking about here, all of these are going to be covered in the system design cohort, right? Everything in depth with examples, with implementations, end to end we are going to discuss, right? So let's start. Now, in order to make sure that you have a good grip on LLD, I would say this topic is kind of like a prerequisite. That's oops, right? Object oriented programming is something that you have to know. And I would say four of the most important topics in object oriented programming that you have to get a good grasp on is going to be abstraction, polymorphism, inheritance and composition. And one very important thing, you need to also understand that what is the difference between inheritance, why you need one thing on top of the other, right? Why one is better than the other, why in what situation one is not going to work, so on and so forth, like the comparison, right? You need to understand the comparison between inheritance and composition, because in a lot of design patterns, in a lot of, I would say, low level design concepts, you will again and again get the dilemma that why exactly we are using inheritance, why not composition, or vice versa. So if you have a good grasp on inheritance and composition, this is going to be good. Now, a lot of people actually ask me this question that, okay, in which particular language we should try to learn all of these concepts? I would say any language that you are comfortable with, be it Java, be it C++, be it Python, be it TypeScript, Golang, anything is going to be good for you. there are a few caveats that you have to keep in mind. The majority of the online resources that you're going to find is going to be in Java. So if you're somebody who has some experience with Java and want to, let's say, explore more things around Python, it's going to be very easy for you because you will be able to very easily translate things with Java to, let's say, whatever language you want to have. But if you ask, with respect to my recommendation, if you have no as such language bias, go with Java. Most of the concept that you'll find online, the tutorials, the articles, the references are going to be in Java. So it's going to be a good journey. I would say if you are somebody who is learning things end to end with plain vanilla JavaScript, then JavaScript has its own way of implementing a lot of things, right? Own way, own fashion of implementing a lot of things. Hence, you need to make sure that you do that extra effort, you go that extra mile and figure out all the design patterns and all the implementation specifically separate for JavaScript. If you want to make your life relatively a bit more easy, go with TypeScript instead of JavaScript if you are more JavaScript enthusiast. Okay. So this is going to be something that is going to be your choice, right? In the course, we are going to focus everything around with Java, right? And we are going to make sure that we do all the implementation as such in Java only. Now, you don't need to be like extremely advanced developer in Java. If you know basic core Java, you are in a good shape altogether. And this is going to form the basic foundation of the low level designs prerequisite. Now, the next topic is also kind of like a prerequisite, but I believe most of the people do not understand this in depth and have very less knowledge around it. I'm talking about solid principles. Now, if you will go to somebody and let's say if in an interview you'll ask somebody that, okay, what are solid principles? There is a good chance that people will give you the definition of solid principle. But when I say understanding and learning solid principles, I am making sure, or I want to make sure that you need to know everything that on application perspective, right? If you want to apply all of these concepts of solid principle, how you're going to apply, what are the situations in which the solid principles are being violated, right? If you see a code, are you able to identify that any one of the solid principle or more than one of the solid principles are getting violated? And if yes, then how can you actually solve it? And then all the important solid principles like the single responsibility principle, right? The open close principle, the Liskov substitution principle, the interface segregation principle, and I would say the most important one, the very, very important one, dependency inversion principle. I believe every single developer should know in-depth analysis and have in-depth understanding of solid principles. Why exactly every single principle is there? What is the main reason when a code actually violates one of them? How can you make sure that in case a code is violating, how can you make it compliant with solid principle with examples in whatever ecosystem you're working with? This is kind of like a must have, right? All of the design patterns that you're going to learn, those design patterns are going to be based on solid principles. If you ask me, then in my initial starting journey of understanding LLD and understanding large code bases, I made sure that I understand solid principles well. If you understand solid principle well, you will realize that 70 to 80% of the design patterns are nothing but some or other level of implementations around solid principle, or they are just seeing that, okay, any design pattern that you pick, you are going to see that there was a situation when a code was violating one of the solid principles, and in order to make sure that the code becomes compliant to the solid principles, there is a technique or there is a design pattern solving it. So keep in mind that after understanding all of your concept with OOPS, understand solid principles. See why do you need single responsibility principle, see examples of open close principle and how open close principle can be solved, get a good understanding of Liskov substitution principle, and then at the last, interface segregation and dependency inversion. These are the main most important one. And once you have good knowledge about dependency inversion principle, I would say also start understanding a very, very important concept, that is DI. What is DI? I'm talking about nothing but dependency injection. Okay, I'm talking about dependency injection, right? If you understand dependency inversion principle good, then you will be able to understand dependency injection also. And dependency injection actually forms the basis of a lot of framework. For example, if you see Spring is having a lot of heavy dependency injection going on behind the scenes. Even in, let's say, Go's ecosystem, you have libraries like UberFX that can do all the dependency injection for you and so on. So what is dependency injection? Why do you need it? And how exactly dependency inversion principle can help us to implement dependency injection? All of these concepts you have to keep in mind. These two things, once your OOPS concepts and solid principle concept, they are going to found the basic foundations. I would categorize them in the foundational concepts, right? This is going to be a foundational concept. This is also going to be a foundational concept. Once your foundational concepts are ready, that's the point when you go, I would say, on the medium level or the intermediate level. That's where you start learning design patterns. And when I say learning design patterns, I don't want you to be in a situation where you are just taking pizza classes, vehicle classes, animal classes, and then just seeing the design patterns. No. I would say that when you're learning about design patterns, see, in a real life situation, in a probable real life use case, what exactly a design pattern is doing and how you can make things implement the solid principle using that design pattern. For example, there are a couple of categories of design patterns like creational, structural, behavioral. I generally ask people not to do so much segregation. Just think about each design pattern kind of like separately. For example, you should start I would say with builder pattern. Now when you're learning builder pattern, don't just see that okay what builder pattern is and how you can make a builder class and how you can then instantiate that class and so on. No, see, why do you need builder pattern? What are the situations because of which builder pattern is required? Like for example, you have a lot of parameters coming up, right? That's not the situation initially that you are going to start with builder pattern. If you want to see builder pattern, start with even more basic. Like let's say you want to create an object and you want to have validations on the properties of the object. Now, how will you implement validations? The validation can be implemented using, let's say, setter methods. What are the problems with setter methods, right? Then you will see that validations can be moved to constructor. But then what is the problem with constructor? That there can be a lot of parameters. How can you solve a lot of parameters? Maybe you can pass a key value pair kind of like a mapping. Key value pair kind of like a mapping will eventually convert things with respect to objects. So you're passing an object in the constructor. And hence the complete story of builder should go. And not just that. See, what are some real life implementation of builder? For example, if you use any RPC ecosystem like grpc, in grpc all the protobuf classes that eventually get created are builder classes. So you don't just have to see why of the design pattern, but where you have to also see where, like where exactly the design pattern is implemented. So always ask this question for all the design pattern, that why do we need this design pattern, where this design pattern will be implemented, and how will it be implemented, right? These are the three most important questions that you should ask for most of the design pattern. For example, there is factory design pattern, singleton, abstract factory. Why do you need factory pattern? What are the situations in which you need to have a factory pattern implemented, right? Then where do you see in real life situation, in real life code bases, where do you see factory patterns implemented? And then at last the situation comes of how to implement factory pattern, right? Similarly, then you can start moving to slightly a bit more advanced patterns, like what is a decorator pattern, adapter pattern. Like most important, I would say one of the most important ones is adapter pattern. See, why do you need facade pattern? Why do you need proxy pattern, right? Why do you need flyweight pattern and so on? And to be very honest, I don't think that you need to learn all of these patterns. Like let's say if you will see on the internet, you will find, let's say 25, 30 odd different patterns. I don't think you need to go to all of that. If you ask me, the first design pattern that I learned was strategy pattern. If you see, I have listed that here as well. You can pause yourself and screenshot all of these patterns. But strategy pattern was one of the first design patterns that I learned. And to be very honest, like 60 to 70% of the problems in my interviews I was able to solve using strategy pattern, because it's such a simple patterns directly implementing solid principle and solving actual real life problem. So I would say, if you ask me like what the most important ones, I would say go with strategy pattern. This helps you a lot in interviews. Iterator is one of the most frequently asked in interviews. Builder is something that you will see actually in real life, right? Factory is something that you will see actually in real life. Adapter is something that you will see actually in real life. Observer pattern is very, very important, not just in, let's say, low level design of backend, I would say, interviews, but in front end interviews also a lot of time observer design pattern is actually asked. Then chain of responsibility, you will see some real life applications of chain of responsibility, and state design pattern also you will see in real life. I would say these are kind of like the most important ones that you cannot miss. Second, I would say the second priority should come to singleton, and I would say decorator pattern and proxy pattern. And then the more remaining ones you can actually target, the better it is. For example, one very I would say interesting design pattern that a lot of people actually miss is criteria design pattern. This can help you to actually implement a lot of filters, right? So let's say and based filter, or based filters, nested filters. If you want to implement, you can learn about criteria pattern. But eventually, if you will see that the basic foundational patterns only make the base, or I would say the implementation of higher level patterns. So you should try to go to every single pattern one by one. You will very easily get, you can screenshot this list, or you can get this list online. GPT can help you with this list. But make sure that every design pattern that you're learning, you see where exactly you will implement it. What are the situations in which you implement it? Then only it is going to make much of a difference. Now, interestingly, the observer design pattern is also very, very important. As I mentioned already, it helps you to also understand the concepts of pub/sub. This is going to be extremely, extremely important. A lot of time in a lot of interviews, pub/sub related questions can actually come up, right? So apart from that, if you see state design pattern, some very important problems come from state design pattern. Like if you will see, people can ask you to design an elevator system, design an ATM system. Both of these can be solved using state design pattern, right? So you need to start also putting problems in place and start solving questions, like some real projects, or I would say some real machine coding problems, like design an ATM machine, design an elevator system. These are very frequently asked questions in startups, wherever you will be having low level design or machine coding kind of rounds, right? Think about designing a logger, how chain of responsibility can be used for designing a logger, right? Think about designing a parking lot. So there are problems which are kind of like much more broader and can also inculcate more than one design pattern altogether, right? Maybe you will be able to implement the stat, like for example, in a parking lot, you might allow the users to either pay by cash or pay by, let's say, card, right? Or let's say pay by a token, for example, some company tokens. So there are three ways to make the payment. The moment you see three algorithmic ways to do something, the direct implementation should go for strategy pattern, right? So you need to start looking at problems, right? And you need to see that in this problem, what are the different design patterns I can actually implement. Interestingly, parking lot problem was the same problem that was asked to me in my Uber low level design interview as well. So again, as I mentioned, and it's not like there are like hundreds of problems that you have to solve. I believe, if you ask me, there are like 10 to 20 most important problems that you should solve, and you should solve them like 2 to 3 times. This will make sure that you have practiced all the relevant problems and you have a good grasp on them, and not just like copy paste. Think about what all design patterns you can have. Think about requirement analysis, solve some problems in like basic CLI interfaces, solve some problems with respect to, let's say, REST APIs, and so on. Some of the problems I have listed here as well. For example, try to solve the problems of some games like tic-tac-toe, chess. These kind of games are going to help you a lot and help you understand a lot of situations. Book my show, a very important problem for understanding concurrency related concepts. So now in low level design and machine coding interviews, sometimes some database related concepts can also be expected to be implemented, right? For example, concurrency related concept, that how exactly you are going to make sure that two concurrent requests are handled. Some concepts around locks, that how can you implement actually locks, right? Some concepts around indexes, that how can you make queries faster. Good practices of REST API, how you can make good REST API with proper JSON requests and JSON responses. So book my show can be a very good problem to actually solve with respect to that. Similarly, e-commerce can be a very good problem, and in e-commerce you can implement more problems, like implementing an end-to-end filter, implementing an order OMS kind of like a mechanism, right? Then you can see patterns like CQRS pattern, right? That how exactly command query responsibility segregation can actually be implemented, right? And so on, how exactly there can be a pub-sub architecture implemented. Then some slightly more algorithmic implementation, something like key value store, how you can implement a key value store. And I would say, if you're implementing the low level design of key value store, do check out the, I would say, case study of, I would say, Facebook's key value store, right? I would like to give you guys this particular task. Figure out what is the Facebook's key value store technology that is used at Facebook, and there's a very good engineering article that Facebook has actually launched. It's like released. It's kind of like a high level design architecture, so just read about it. But yeah, it would be a good read. But yeah, like in low level design, key value store is a very interesting problem to solve. Card game can be something that there are different type of card games. Tic tac toe, as I mentioned, is a very interesting problem to solve. And there are more problems. Like for example, people can actually also ask you to implement a distributed queue, right? Distributed queue, something like, let's say, RabbitMQ, right? These kind of architectures people can actually expect you to implement and show them, okay, how it works. Things like vending machine, people can actually ask you to implement a vending machine altogether, right? I have seen a lot of interesting interview problems, like coupon management system, right? Library management system, right? And then parking lot, I've already mentioned. So these are some really interesting problems, and very frequently asked questions as well. So after learning design patterns, the advanced level comes with these problems, because these problems are going to have a lot of classes. It will be kind of like end-to-end projects, if you will see it with respect to I would say implementations. So solve 10 to 20, I would say, good problems, right? A lot of problems I have listed here. I would say just GPT it and you will find it very easily. And I would say read online solutions also, that how other people have actually implemented these, and see and take inspiration from other designs as well. No low level design, no machine coding is actually, I would say, the best implementation. But yes, you are going to actually get a lot of idea that what is the thought process of the author, because your interview situation is going to be different and you will be having different amount of time to implement the same thing. So just get a lot of idea and have your own implementation ready as well. And keep everything in mind. All of these low level design concepts we are going to cover end to end. A lot of these problems we are going to cover end to end in our system design cohort. Do check out the system design cohort altogether. We have also added some, I would say, bonus section around testing. Like in low level design, I would say with respect to interviews, it's not very important, but with respect to actual engineering effort, testing is kind of like very important. So we have an introductory module on testing. We have an introductory module on concurrency, right? How exactly you can create threads, how what are threads, how they are actually helpful, so on and so forth. So these are some very, very interesting concepts that we have also added, and I believe are very useful for better engineering applications as well, right? So I would say if you are able to implement and prepare all of this in the given sequence that I have mentioned, you will be in a very, very good shape, right? These are all the concepts that I also learned and implemented. You can see I have specifically mentioned concurrency and testing here as well. So this was all about low level design. Let me know in the comment section, are there, if you have any questions or you have any suggestions or you have some design patterns in your mind that you believe are very frequently asked in interviews, but I believe I have listed down all the major ones here. Now this was all the discussion around low level design, but we still have the discussion on high level design pending. Now, there is a lot that I have to discuss in high level design as well. And I believe the video is already pretty long. So let me know in the comment section if you want me to have a separate part for high level design. I thought I can give you a good brief in this video only, but I believe we have given a very in-depth analysis on low level design. So let me know in the comment section if you feel I should put the high level design roadmap also. If we will get a good response, then I'll try to put it as soon as possible, probably the second or the third video from here. I can put that as high level design roadmap as well. But I would say do let me know your thoughts in the comment section around low level design, right? I will also make sure that during the course, this is kind of like an added offering that we have started, that we are going to see a lot of things specifically with respect to company interviews like Flipkart, Walmart, Myntra, Uber, Amazon. These companies have a lot of interesting ways of asking machine coding rounds, LLD rounds. We'll try to keep dedicated focus and specific classes for these machine coding rounds of some selected companies that we have shortlisted, which are going to give you a lot of learning altogether. So a lot of extra add-ons we have done this time with system design cohort as well. So do check out the system design cohort. All the details are mentioned in the description section below. Check this out and you will definitely find one of the best resources on the internet to actually prepare for your system design interviews. That being said, let's wrap this particular video here. We're going to meet soon in the next set of videos. Till then, take care. Bye bye. I'm Sanket Singh signing off.